Okay, probability using two-way tables and a tree diagram. I'll just do some examples basically because you know the basics of, or you should know the basics of probability. We just go over it first of all. So all the outcomes that, must sum to 1. So probability is 1 is certain to happen, 0 is impossible. Yeah. Looking through two-way tables, this is a two-way table. You have at the top here, year groups, and at the side here, girls or boys. And you might be asked to fill in the table, and you might be asked to find a probability from a table. So that might be a single probability or conditional probability. So here you just look for values where there's only one missing. So the first one you could look is here. You could look along the bottom here if you want to, or you could look along the side here. These have only got one value missing, so you can work your way through it. I'm not going to particularly go over this. So that's 133. We can then fill that one in, and then fill that one in, and then fill that one in, fill that one in, fill that one in. Okay, so you're just looking for where's only got one space missing, and then if it's only got one space missing, with like any equation, one unknown and one equation gives you, you can solve it. And so that's how you might fill in a two-way table. Okay, so let's have a look here. So again, we're just going to go over probability. So the probability is the number of times that event can happen and the total number of events. So if I want to find the probability of picking a letter from probability, and the probability that it would be a B, there are two B's in probability, and so it's 2, which is the number of events, out of how many letters there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 of letters in probability. So it's 2 out of the total 11. This is assuming that we're picking randomly. Okay, so put all the letters in a bag and pull it out randomly. So 2 out of 11. O, there's one O. Z, there's no Z's. Okay, so 0 out of 11, so probably 0. So remember, this is the union. So what's the probability of P, R, O, B, A, I, L, T, or Y? Okay, like we said before, if I add all those probabilities up, it's 1. Yeah, and that's just so that's probability in its basically in its simplest form. If we've got independent events, so an independent event are events that don't depend on each other. So rolling a 6 on a die and pulling a king from a pack of cards, it doesn't matter what I get on the die, whatever I pick from the pack of cards, it doesn't affect. If I pick a girl and then a boy from a class, however, that is dependent, because if I pick a girl first, then picking the probability of picking a boy is increased because I've picked a girl, and so there's one less person in the class, and so the probability of picking the boy second is reduced than if I pick a boy, if I don't pick a girl first, because it depends on who I pick first. So this is these two are dependent on each other. This one is not independent, not dependent, so it's independent. So if I spin this spinner twice, a blue then a white, these two are independent because it doesn't matter what I get first time, the probability of me getting white second is still the same. It's still 1 out of the 8 things that are there. And so the probability of picking a blue is 3/8, probability of picking a white is 1/8, and if I want the probability of a blue then a white, so 2 independent events, and I want the probability of them, then I have to multiply them together. So in this case, it's 3 out of 64. So what this means is, if I spin this 64 times, I would expect to get blue then white, or if I spin it twice 64 times, I would expect to get blue then white 3 out of those 64 times. Now, clearly, this is theoretical, and it's unlikely, maybe, but well, it's 3 out of 64 times I'm going to get blue then white. Okay, So let's have a look at some questions. Here, what's the probability of picking a boy? If I pick a person at random from this group of 831 students, what's the probability of a boy? Well, the probability of a boy is 407, because there's 407 boys out of 831. Okay, what's the probability of picking a year 10? Well, there's 256 year 10s. Okay, out of the 831 students that there are there. Okay, a year 9 girl. So a year 9 girl, there's 154 year 9 girls. So 154 year 9 girls out of the 831 students. Okay, so those are all fairly straightforward. This last one is conditional. Okay, so it's given that they're a year 10 student. So we know they're in this column, and we want a girl that's in this column. So there are 121 girls in year 10, but we're only doing it out of year 10, so it's out of 256. Okay, so this is where lots of students fail on these questions, because they still do it out of 131. Okay, if it says given, it means it's conditional. Okay, or it might say given that they're a year 10 student, what's the probability of a girl being chosen? Okay, so be careful of the questions. As soon as you see given in a probability question, then there's a chance that to check that it is a conditional probability question. Okay, in which case the amount of events is reduced. Okay, so let's have a look at some tree diagrams. So here, complete the tree diagram and then work out probability. So this is a really standard question. So the probability she win a badminton match is 9/10. Probably she win a tennis match is 2/5. Now these are independent events. Okay. Now remember, on the arms of a probability of a tree diagram, they must sum to 1. Okay, so that's 1/10. Here, that will be 3/5. And again here, 2/5 and 3/5. Work out the probability that Hannah will win both matches, and the probability that she wins both matches is along this. Okay, now these are independent events. Okay, and so we multiply along the arm. So 9/10 multiplied by 2/5, okay, equals 18/50. Okay, so the probability that she wins both matches is 18/50, because that's the only one where she wins both. Everywhere else, she loses one of the matches. Yeah, you don't have to reduce this fraction. 18/50 is fine to say it. Okay, if it was wins one match, then it would be up here and along here and down here and along here. So you would do the same to find the probabilities of anything here ending, but then you would add these two up at the end. Okay, so you multiply along the arms, but then add up at the end. Okay, let's have a look where the probability changes, conditional. So this time we take a marble from a bag, and then we take another marble from the bag, but we don't replace it. Okay, so here is the same as we did before. So 5/8 there is 3/8 there, because it must sum to 1. But here 4/7, because we've taken our marble out, we've reduced the number of reds and we've reduced the number of marbles. So here it's 4/7. Here the greens is the same, but it's 3/7. Here we go green, red. We've still got 5 in there because we've taken one of the greens out, but it's over 7 this time. Okay, and then here we've only got 2 left. Okay, check that they add up. 4 and 3 make 7, 5 and 2 make 7, and so you know that it is. So work out that Dwayne takes marbles of different colours. Well, in this case, it's this arm here, red then green, or green then red. And like I said before, you multiply it along the arms, so 5 over 8 multiplied by 3 over 7, and here it's 3 over 8 multiplied by 5 over 7. Okay, so this is 15 over 56. This is 15 over 56. Okay, and so the probability that they're two marbles is them two added together, which is 30 over 56. Now, if you want, you can leave it like that. If you want, you can put it in a reduced fraction. If you want, you can write it as a percentage. If you want, you can write it as a decimal. Doesn't matter, but writing it as a fraction is just simple, easy, and you don't get any as soon as you do more calculations, you're open to mistakes. Okay, so that's the end of the chapter.